Okay, let's take a look at this example. So as you can see, the student in this example did not get the first part correct. They answered 0.9987, whereas you can see the correct answer is 0.0166. So let's take a look at how we need to go about doing this. So remember, these are normal approximation to the binomial probability distribution problem. So the first thing we have to do is just make sure that our n times p times 1 minus p is going to be greater than or equal to 10. So let's check that. Our n value is, of course, they're telling us that this survey was administered to a total of 221 students. So our n value is 221. Probability, they're of course telling us, according to the study, 51% of all males between ages of 18 and 24 live at home. So as a decimal, that probability will end up becoming 0.51, which means if you did 1 minus p, that would be 1 minus 0.51, which, of course, will come out to be, let's see, what will it be, 0.49? Yeah, 0.49. So now if we multiply all of these together for our example, we are looking at 221 times 0.51 times 0.49. Just as a reminder, I had kind of mentioned this before, but this value, you can also call it as Q for that 1 minus P if you like. All right, let's multiply all of these together and let's see what answer we come up with. So when you multiply n times p times 1 minus p or q, you are coming up with 55.2279, which is obviously greater than the number 10. So obviously we can go ahead and proceed with approximating this binomial variable. Alrighty, so now let's move on to the next step. So the next step we need to do is calculate our mean and standard deviation for these binomial, normal approximations. So let's take a look at those. So for the mean for this variable, remember the formula is n times p, so that's going to be 221 times 0.51. Let's see, what does that come out to be? So this guy comes out to be 112.71. And let's take a look at our standard deviation. So remember, standard deviation is sigma sub x, which will come out to be n times p, which is what we have from that mean up here, and then minus, multiplied by 1 minus p, and then, of course, since this is a standard deviation, we end up taking a square root on this. So then you have 221 times 0.51 times 0.49, all of those we multiply together, and then you take a square root on top of those numbers. So let's take a look at what these guys come out to be. Alrighty, so our standard deviation is coming out to be approximately 7.431547, and this number keeps going on. But how about we approximate this to 7. Okay, so now that we have the mean and the standard deviation, we're ready to tackle that part A. So you can see in part A, they are talking about, finding the probability. Let's go ahead and there we go. Let's do this over here. So when they're asking you to find the probability of x greater than equal to 129, remember with the normal approximations to binomial distribution, we have to make, adjustments. So if you can see right over here, since we are looking at greater than equal to, for our exact probability, you have to make adjustments by taking that A value and subtracting 0.5 from it. So we will need to do the same thing with our probability of X greater than equal to 129. So let's come back to our example over here. And to make that adjustment, oops, we will go ahead and rewrite this guy's probability of X greater than equal to 129 minus 0.5, which, of course, ends up giving you a probability of X greater than equal to 128. Sorry, 0.5. Okay. So now that when you're calculating your probability, remember you use the formula, and I guess I'm going to change it. Here's Z equals our data value, which is 128.5, minus you subtract the mean from it, which will be our 112.71. And then since the standard deviation is coming out to be, non-terminating decimal, I'm actually going to leave that as it is so that, we don't run into any rounding errors over here. So I'm actually going to leave it as square root of 221 multiplied by 0.51 multiplied by 0.49. And you can put that all in your calculator at one time. So let's go ahead and subtract our numerator, 128.5 minus 112.71, which will end up giving us 15.79, and then you can go ahead and divide it by this standard deviation. And let's see what this guy comes out to be. So divide by square root of 221 times 0.51 times 0.49. Alrighty, and we are coming up with 2.1247. And of course, the number again keeps going, but since this is a z-score, we are going to round it to 2 decimal places. So we will end up with 2.12. You have a 4 after that, so it will not change the 2. So it will stay at 2.12. Now, once you find your z-score, then, of course, you can go into your standard normal distribution table and try and find what that probability is going to be. So the one thing you will have to keep in mind, since this was a greater than probability, and if you think about this as being our normal curve, our mean is going to be in the middle over here. So since we're talking about it being greater than 128.5, you're looking at this area over here. But by default, our standard normal distribution table always gives you the area, which is going to be below that number, right? So it's always giving you the area to the left. So when you look up that z-score of 2.12 in your table, it's actually going to give you this area here, which is shaded in the red. So to calculate the probability for our example over here, you will need to take 1 minus, whatever this probability comes out to be. So let's go ahead and do that and take a look at what probability we're getting. So I have actually downloaded the standard normal distribution table over here. And we need to go to positive 2.12. So I need to go towards the positive side. And I know it's going to be a little difficult to see with all of this, but we need to be, in the third column over here for the 0.02. And then we need to look for 2.1 on this left hand side. So you will actually be going to 2.1 over here. And then remember the third column is the 0.02 column. So this is actually going to be your probability that you are looking at. So for this z-score of 2.12, your probability comes out to be 0.9830. Alrighty, so once we find that, we can now go ahead and bring it to our probability calculation over here. So let me go ahead and come back to our example over here. There we go. This might be a little better to look at. So let's get rid of some of these lines here. Alrighty, so you found your probability. Now that's the number you will need to subtract from 0.9830, subtract that from 1. So 1 minus 0.9830 is giving us 0.017, which you can see is close to the answer you came up with. And I believe they have a tolerance. So you can see how they have a tolerance of 0.002. So I think you should be okay with this calculation. So keep in mind of, where the probability is. So like I said, since this was greater than, you were looking for the probability, which I have shaded in blue in my normal curve. And the table by default gives you the area on the left. So that's why you needed to do 1 minus the probability 0.9830 to come up with your final answer. So this is the answer you are looking for. Okay, I hope this helps you. Okay, take care.